Hello and welcome. On lesson 1.14, composition of functions, you're going to learn how to compose two functions and also evaluate the composition of two functions, including identifying the domain of this new composition. So let's review first and determine domain of compositions. So let's review again how to identify the domain of a function. Now, recall that the domain is going to be the largest set of real numbers, again, in which f of x, the y output values, are real. They are an actual number. Those, again, are going to be true for almost every function, with the exception of this function here, and we'll talk about the next one, the root function. So on these examples, we identify the domain by excluding any value of x that will make our denominator, which is x plus 6, equal to 0. So solving this equation, we find that x equals to negative 6. So our domain will exclude that value of x and only include the real numbers from negative infinity to negative 6, and then jumping over negative 6 all the way to positive infinity. So that's one way of excluding numbers in domain, and only these type of functions where we have an x in a denominator has an exclusion. The other type of function that excludes numbers from the domain are the square root functions, or any even root functions, not just square roots, but any even number. If in this case there's an invisible 2 right here as the index, but if that index was a 4 or even a 6, 8, or 10, and so on, any even number, then the way we find the numbers that get excluded are going to be numbers that are greater than 0, because we need this radicand always to be a positive number. So what we do on these type of situations to determine the domain, we get our square root or the radicand in our square root, the x minus 9, and have it be greater than or equal to 0, and we solve this inequality. So this simply requires us to add 9 to both sides, and the value of x is going to be greater than 9. And this correlates and again lines up exactly what x minus 9 does in terms of transformations. By subtracting 9 to the x inside here, we are horizontally shifting our square root function, which kind of looks like this, 9 units from the origin to the right. This is why we're only allowed to plug in numbers for x greater than 9, because we're shifting our graph 9 units to the right. Look what happens when I pick a number again to the left of 9, less than 9. For example, 0. If I plug in 0, a number less than 9, I get 0 minus 9, which is equal to negative 9. And while the square root of 9 is equal to 3, the square root of a negative 9 is not a real answer. This is an imaginary number. This is not a real number. So it cannot be found anywhere on our x and y axis. So that's why we're only allowed to pick numbers greater than 9. So, and again, and this is what we do for any situation where we have an even root, so where this index is an even number, we simply have to get the radicand, have it be set greater than 0, and solving that inequality tells me what values of x I'm allowed to use. So right here, I'm only allowed to use numbers greater than 9. So our domain, and move this over here. So our domain is going to be the values of x greater than or equal to 9, which on the number line is going to be a closed circle above 9 pointing towards positive infinity, which in an interval looks like this. It's a closed, half open interval. So on 9 it's closed, and going towards infinity is open. So let's see. Pause the video and find me the values of x greater than 0, or find me the values in which 6 minus 3x is greater than 0, and that's going to be your domain. So let's check your work. So right here, to solve this inequality, we'll subtract 6 from both sides, which is going to be -6. We're going to divide by -3, and we get +2. But since we're dividing by -3, that's going to switch that inequality because of the division of -3 to both sides. So instead of having to be greater than, it's less than, still equal to, a +2. So our domain is going to be all of the values of x less than or equal to 2. And as a number line, that's going to be a closed circle on +2, but this time pointing towards -infinity on our horizontal x-axis. As an interval, that looks like this. Now, if that square root is on the bottom, then the only difference is that we still set it greater than 0. We just don't put the equal sign underneath it, because remember, applying again from example number 1, we cannot have our denominator of 2x plus 8 equal to 0. So we have to exclude anything that will make this equal to 0. And because of the square root, we have to have it be greater than 0. So it will not have the equal sign. So when the square root is in the denominator, we just simply set it greater than 0 instead of greater than or equal to 0. We just exclude the equal sign. So here, by subtracting 8 to both sides, we get -8. We're going to divide by a +2. So x is greater than -4. We don't switch the sign this time. Again, it does not switch because we're dividing by a +2. So this inequality is going to stay the same. It does not switch directions. So our domain would be all numbers greater than -4. This time we have an open circle above -4 pointing towards +infinity. Again, because of the no equal sign, open circle. So as an interval, that will be an open interval from -4 to +infinity. Now, let's go into how to compose functions. So that's just a quick review on how to find the domain of functions. Let's go into the composition of functions. So another way of combining two functions is to form the composition of one function with the other. The composition of the function f with the function g is defined as the following. This is the composition, which is read as f of g of x. And what this means, what this operator right here does, this little open circle looking thing, it tells us that we are composing one function into the other, specifically composing g into f, which means that we're simply substituting the function g into the function f. So for example, let me go over the domain stuff and then we'll do the example. So because of this, the domain of this composition looks like this. So let me give you a real world example. Let's say again that I want to buy a computer again from Best Buy. And Best Buy is offering me again a $300 discount. And I have a coupon that gives me 15% off. So I'm only paying 85% of the price. So let's say I have again, this is the price of the computer. And the first function g, Best Buy, is going to get whatever the price of the computer is and take away $300 off. So let's say the computer again is $1,000. So $300 the $300 off will mean that the price is now $700. Now, if I'm allowed to use my coupon that is 15% off, I'm only going to pay 85% of that price, of the price of this $300 discount. So I'm only paying 85% of those $700, not the 1,000, but of that $700, which is going to bring my price to $595. So this is an example of what a composition function does. We start off with one value, we plug it into a function, and then that answer gets plugged into another function to get a final answer here. And the domain of f of g, the domain of this entire thing, is starting off by what numbers we're allowed to use, and then what numbers we're allowed to use again at the very end for the function f. So let's look at an actual example, a little bit more abstract example. So here. So let's say we have the composition of the function and we want to compose f with g as it's indicated here. So this means that we want to get the function g and plug it into f. So we want to get f of g of x, which means we want to get the function g and plug it into f. Well, f multiplies x with 3 and then adds 9. So we're going to write f as 3 times the value of x plus 9. And again, what this means is that we're simply plugging in g into f. So I'm literally going to plug in the entire function g into, in this case, this one value of x. So 3 gets multiplied with x squared minus 6, and then we're going to add 9. So all I've done was simply substitute in g into f, and that's what this means. So to simplify this, we distribute, combine like terms, and there is my answer. So this is the composition of f of g of x. Now, what is going to be the domain of this? Well, let's start first with what we plugged in. Since we're plugging in g, g has no restriction. So the domain for g, let me move this down. The domain for this is going to be all real numbers. I'm allowed to plug in any all real numbers since there again this is not a square root and it's not in a fraction. It's not underneath a value. So this has no restrictions. Now, after I plugged in, I get this value here, and this one also has no restrictions because there's no square root, and this is not underneath like 1 or anything like that. So there are no restrictions. So the domain is going to be all real numbers. Now, to evaluate this function and to figure out what the function is when x is equal to -1, this one, you don't want to plug in -1 into g first and then plug in that answer into that one. You want to do the composition first. First, figure out what f of g of x equals to, which we already did on example 1. We know using, again, f as 3x plus 9 and g as x squared minus 6, we get 3x squared minus 9. Yes, minus 9. So using that composition, now I want to plug in -1. So the answer is -6. So on compositions, you want to do the actual operation first to create the new function, and then you want to plug it in. Again, this is different from the adding and operating by the adding, subtracting, multiplying, and dividing one. On those, it's easier to plug in the number first into the two separate functions and then do the operation. But right here, because we're plugging one function into the other, I would have to, in order to do that, I would first have to plug in the 1 into the g. So I would plug in the -1 into the g. And then plug in that answer into the f. So then I would have to plug this into the f. I still get the same answer, but notice again that it's a little bit more work because I have to, again, plug one answer into the initial number into one function, and then that answer gets plugged into the other function to get the composition of f of g when x is equal to -1. It's easier to first figure out what the composition is, plug in that number, and then get my answer from there. So let's look at another example. Okay, so here again we have the composition of f of g of x, which means that we're going to plug g into our f function. So we're going to get to this thing here and plug it into the x on f. So that would be -3 times x, which we're going to replace again with the square root of x minus 5. I'm just going to use parentheses as a placeholder for right now. We're raising that x to the second power and then adding 1. So again, I'm doing the substitution and replacing my x with the square root of x minus 5. To simplify this, I have to first look at the exponent and raise the square root of x minus 5 to the second power. And because these two things are inverse operations, they're going to cancel each other out. So in the parentheses, I'm only going to have x minus 5. And the square and the square root cancel each other out. I can now distribute the -3 and combine like terms, and I end up with my answer. So this is the composition. This is what f of g of x equals, -3x plus 6. Now, to figure out the domain for this, I have to see if there's any restrictions at the beginning, and there is. Because of the square root, x minus 5 has to be greater than or equal to 0. And by adding 5 to both sides, x is greater than or equal to +5. So I have the restriction that x has to be greater than 5. After plugging in all values of x greater than 5, again, we end up now with this. So by plugging g into this, we end up with this answer. And this doesn't have any additional restrictions. There's no other no square roots, nothing else to restrict. I can plug in any numbers that I want here after I plug in any numbers greater than 5. So the domain for this is going to be all the numbers greater than 5. Which is this. So to get the domain of the composition, we have to see what restrictions there are in the function that we're plugging into the other function, and then at the very end, see if there's any additional restrictions. And in this case, there are no additional restrictions, only the restrictions at the very beginning. So as long as I plug in numbers greater than 5, I'm going to get, again, real numbers out of this, and this is going to also just give me real numbers. There's no restrictions on what numbers I can plug in here. So my domain is 5 to infinity, including 5. Now to evaluate this, again, given that we already did the composition and know that this is equal to -3x plus 16, I'm simply going to plug in the 7 into the x. So this is your answer. So f of g of 7 is equal to -5. Now let's look at number 5, example number 5. Notice that the order is now different. Here we want to get g of f of x. So we switch the f and g, which means now we're going to plug in f into g. So we're going to get to this function and plug it into this x. Let's change the x on top to a 7. So let's use a 7 up here. So there's going to be 7 over x squared plus 4. So to plug in f into g, g is 7 divided by our x to the second power plus 4. And again, like I said, we're replacing the f into that x on g. So the square root of 2x minus 8. Just like the last example, the square root and the square are going to cancel each other out. So in our denominator, we have the 7 on top. And on the bottom, we now have 2x minus 8 plus 4, since the square and the square root cancel each other out. Combining these two terms, that's going to add up to a negative 4. So this is my answer. This is the composition of g of f of x. Now let's get the domain of g of f of x. So we start by first looking at what we're plugging in. Since we're plugging in there, again, and this has a square root, we're going to start by first getting 2x minus 8, having it be greater than 0, and see what that gives us. So that's going to be values of x greater than 4. So we're only allowed to plug in into this values of x greater than 4, which means we're only allowed to plug in, again, numbers for x that are greater than 4. Well, right here, because this has a denominator, this also has a restriction. For this one, we're only allowed to plug in numbers just as long as 2x minus 4 doesn't equal to 0. So solving this equation, we'll add 4 to both sides, divide by 2, and we get that x equals 2. So that number gets excluded from the domain. So x cannot equal 2. Because if it does, then we divide by 0. 7 is going to be divided by 0, which again is undefined. So our domain has to be values of x greater than 4, excluding 2. Well, 2 is already excluded because from the very beginning, we're only allowed to plug in numbers greater than 4. And 2 is not greater than 4. So we automatically, again, don't have to worry about including the 2 because this already excludes it. So our domain here is going to be 4 to infinity. And to evaluate this function, so 7 over, what was it? 2x minus 4. We simply replace the x within this situation with 9. So that's going to be 7 over 2 times 9 minus 4, which equals 7 over 18 minus 4, 7 over 14, and that reduces to half. So there's your answer. And let's do one last one. Here, another example where we're plugging in f into g. We're getting the composition of g of f of x. So we're plugging f into g. So again, we're going to plug this into this x right there. So we have 1 over x, which we're going to replace with 3x minus 4, and there's our answer. We can't simplify this any further, no like terms, so this is the composition. Now for the domain of g of f of x. Well, since we're plugging f into g, f doesn't have any restrictions. So for f, our domain is going to be all real numbers. So this one doesn't have any restrictions at all. So all real numbers. We can start off by plugging any numbers that we want. Now, since we're allowed to plug in any numbers that we want, we need to see, okay, and 3x minus 4 is in the denominator. We now have to consider, okay, of all of these numbers that we're allowed to plug in, which numbers has to be excluded? Because if I plug in anything, there's a possibility that we end up dividing 1 by 0. So to find out what that number is, we're going to get our denominator of 3x minus 4, set it equal to 0. And solving this equation, we get that that number is 4 over 3. So here, we have to exclude 4 over 3. We cannot have x equal to 4 over 3 because then we end up getting 1 and dividing it by 0, which is undefined. So of all the real numbers I'm allowed to plug in, ultimately, I have to exclude 4 over 3. So our domain would be all real numbers jumping over positive 4 over 3. So this is your domain. And to evaluate this, again, since we already did the composition, we now simply substitute the x with 7. So this is 1 over 21 minus 4, and that equals to 17. So this is your answer. And there you have it. So if you have any questions, send me a message on Mind or through email. And like usual, I appreciate you watching, and I hope you have a great day.